Greetings. This AOS-CX 10.12 update video will cover the newly introduced application-based policy feature. My name is Matt Fern, and I'm a technical marketing engineer with the HPE Aruba networking switching team. Here's a quick reference to a few acronyms, abbreviations, and software components referred to during this video. First, we'll start with a quick review of application recognition. This feature, introduced in AOS-CX 10.11, uses a deep packet inspection engine running on the switch itself to enable local identification of application flows generated by wired clients connected to the switch. One of the key benefits of app recognition is that it allows for deployment of access control and policies based on those application flows. This functionality has been introduced in AOS-CX 10.12 in the form of application-based policy, which extends application recognition functionality to the AOS-CX policy engine. This permits network admins to allow or disallow authenticated user or device access to specific applications or protocols, with policies enforced at the user role level instead of only on specific interfaces. App-based policy is supported by local and downloadable user roles as well as by device profiles. App-based policy is an access layer technology which is designed to be deployed at the network edge where AAA is deployed for network access control. There are three primary deployment methods supported by app-based policy depending on the network topology and deployed authentication services. The first employs ClearPass Policy Manager and downloadable user roles, which is the most flexible and scalable deployment method as it significantly reduces the amount of configuration required per switch. Nearly all app-based policy configuration, including classes, policies, and user roles, are defined in ClearPass enforcement profiles, a single standardized AAA configuration to enable switch communication with ClearPass. Use of downloadable user roles and any required role ID mappings can be deployed en masse via Central, NetEdit, or any other API-based configuration platform. The second method uses either ClearPass or a third-party Radius server with local user roles. This deployment method requires more switch configuration as all ABP classes, policies, and user roles are defined on each access switch, but it can be used in environments where third-party Radius servers are utilized for network access control. The third and final method utilizes device profiles and local user roles. This deployment method is the least flexible of the three, as it is limited to a total of 16 device profiles per switch and requires all ABP-related configuration to be defined at each switch. However, it has no dependency on external applications or other network infrastructure, and it may be sufficient in smaller environments with a limited number of connected devices. So with that, let's dive into how app-based policy actually works. First, we'll start with platform support. App-based policy is supported on the 6300 switch family, both standalone switches and VSF stacks, as well as the 6400 chassis switch with version 2 line cards and the system profile set as version 2 default. This is based on the requirements for the underlying app recognition feature. Next, we have the per-platform scale figures for the app-based policy feature, including the number of application flows per system, line card, or VSF member, the number of classes per system, class entries per individual class, as well as per system, and then policies and entries per system and policy. Note that the 6300 scale figures are the same for standalone switches and VSF stacks, and the 6400 version 2 line card scale is different for the two line card part numbers specified in the third column. There are a number of prerequisites to deploying app-based policy in AOS-CX 10.12. First, for the CX6400, the system profile must be set to version 2 default, which means that only version 2 line cards will operate in the chassis. Second, IP source lockdown extended mode must be disabled. The app recognition feature requires one hardware hash table that is shared with the IP source lockdown feature, so disabling the extended mode frees this table for app recognition use. App recognition itself must be enabled globally as well as on either an interface or user role that is utilized by authenticated clients. Port access authentication, either 802.1x or MAC authentication, or device profiles must be mapped to local or downloadable user roles. Now, if you're using app-based policy with downloadable roles, ClearPass enforcement profiles containing those roles must also contain all app-based policy classes and policies themselves associated with each of those roles. Lastly, a role ID must be mapped to each user role name associated with an app-based policy. Now, despite using the group-based policy command syntax in the CLI, we do not require you to otherwise configure or globally enable group-based policy on the switch. We only require the role ID mapping itself. For downloadable user roles, that role ID is mapped to the role name as it is defined in the enforcement profile itself, and that role ID mapping is always defined on the local switch, not in the enforcement profile. Now let's talk about the components of the app-based policy feature itself. The first is the ABP class. We've defined two new class types, ABP IP and ABP IPv6, to permit classifying application traffic for policy applications. The class definition syntax for ABP classes is identical to standard IPv4 and IPv6 classes, except that we've added two attributes, app category and app name. The app category uses the top-level application categories defined by the app recognition feature, while the app name attribute matches only a specific application within that specified category. You can use the keyword any for either the application category or application name itself to either match all app categories or all apps within a specified category. The count keyword specifies that packets matching that rule should increment an associated hit counter, and we do not utilize the source IP address for ABP rule lookups in the switch TCAM, so you can only use the keyword any as the source IP in an ABP class rule. The second major component is the app-based policy itself, which is a new port access policy type, ABP, that we've added to define the actions that will be taken on user traffic that matches the class rules that you've defined. The default action for any policy entry in an ABP port access policy is permit, so unless you specify action drop, the class referenced in the policy will be permitted instead. To apply an app-based policy, it must be associated with a user role, either local or downloadable. All app-based policies end with an implicit deny rule that drops any application traffic that has not been explicitly permitted by that policy. Finally, whether using local or downloadable user roles, the role ID mapping must be defined on the local switch and cannot be contained in a ClearPass enforcement profile. When deploying app-based policy with downloadable user roles, the ClearPass enforcement profile must contain not just the user role itself, but also any associated app-based policies and required classes by those policies. The class and policy names defined in the enforcement profile must not conflict with any that have been locally configured on the switch, and ClearPass enforcement profiles cannot contain the role ID mapping that must be configured locally on the switch, referencing the role name as defined in the enforcement profile. So now let's talk about how these components work together to apply app-based policy to user traffic. When a client is authenticated on the switch and assigned a user role associated with an app-based policy, the switch daemon will parse the policy and program all associated rules into the switch TCAM, using the role ID mapping as the source role ID for rule lookups. When we detect a new flow from an authenticated client, the app recognition feature will kick in and start processing the first few packets of that flow to classify and confirm that flow's app ID. Now, while that initial classification is in process, we do not apply any app-based policy rules, including the implicit deny. We permit the traffic to pass to allow accurate classification of that app ID. Once that classification is completed, we will start applying the app-based policy actions via the rules that have been programmed into the TCAM for that flow. It's important to note that if the number of application flows were to exceed the size of the app recognition flow table, application of app-based policies for new flows in excess of the table size would fail. This represents a potential vulnerability as a malicious user or process could bypass app-based policies by flooding a switch with application flows in an attempt to overflow the flow table. To mitigate this issue, AOS-CX 10.12 adds a user-configurable flow table overflow behavior. The default setting drops new flows for affected source roles on the affected system, line card, or VSF member when a predefined flow table utilization threshold is exceeded. As an alternative, warning messages can be generated in the switch event log when the threshold is exceeded, permitting app flows without application of app-based policies. When app recognition flow table utilization on a system, VSF member, or line card exceeds 80% of the flow table capacity, the app recognition daemon will set database flags for any source roles on that affected device. Once those flags are set, new TCAM rules are programmed for those source roles to drop all new app flows. When flow table utilization on that device drops below a reset threshold of 70% of table capacity, the app recognition daemon will clear those database flags for source roles on the device, which will trigger another TCAM rule update to remove the rules that were programmed earlier, which then restores normal app-based policy functionality. So now that we know how app-based policy works, here's how to actually deploy it on switches in your environment. The first step is to enable app recognition globally, which is a prerequisite for app-based policy to function. Please note that app recognition does require an AOS-CX Advanced Software license. As an optional additional step, you can configure an alternative action to be taken when the app recognition session limit is exceeded, which is 80% of the flow table capacity. Remember that the default action is to drop all new client flows when the session limit is exceeded. The alternative action is to only generate event log warnings when the limit is exceeded. From this point, the steps to deploy app-based policy depend on the selected deployment method. We'll start with local user roles. Create at least one ABP class from the global config context using the class type ABP IP or ABP IPv6. From each class context, create a numbered sequence of attributes to match or ignore user traffic by either application category or individual app ID. In this example, the social classes defined match IPv4 and IPv6 traffic to and from Twitter, Facebook, and Classmates, while the catch-all classes match all other application traffic. Once you've created your classes, use the show class ABP-IP and show class ABP-IPv6 commands to display the defined classes and ensure that they are defined as you intended. Now it's time to create the app-based policy itself using the ABP port access policy type. Create a numbered sequence of policy attributes, each matching one of the ABP classes created in the previous step, and specify an action for each attribute. Because the default action is permit, this action will be used unless action drop is explicitly specified for a given class. Once the policy has been created, validate it using the show port access ABP command. The last steps in the local user role deployment method are to associate the app-based policy with a role and create the role ID mapping. From the port access role context, use the associate ABP command with the name of the new policy. If app recognition is not already enabled at the interface level, it can be enabled via the user role instead. Finally, from the global config context, create the role ID mapping to a valid integer value using the gbp role command. Remember that no other group-based policy configuration is required. For the downloadable user role deployment method, the first step is to create a new ClearPass Policy Manager enforcement profile. Set the profile type to Aruba downloadable role enforcement, the role configuration mode to advanced, and the product to AOS-CX. Under the Attributes tab, select the value labeled Enter Aruba Role here to open the role editor. Enter the app-based policy classes, policy, and port access role to be used with this enforcement profile. Select the Save icon at the right edge of the line once you're done. Remember that the role ID mapping to the role name entered here must still be done on the local switch. This will be completed in a later step. Under the Summary tab, ensure that the role appears correct as entered, then select Save from the bottom right corner. The next step is to create an enforcement policy that will be mapped to the enforcement profile just created. Select the Add button in the upper right corner of the Enforcement Policy page. Under the Enforcement tab, specify a policy name and choose the enforcement type Radius. Select a default profile to be applied to any authenticated client that does not match at least one of the rules defined in the following step. Under the Rules tab, create at least one rule that specifies a condition to be checked during client authentication. The example rule shown here checks for the presence of the authenticating user's ID in the ClearPass local user repository. Once each rule has been created, select the Save icon at the far right end of the Rules row. After all rules have been created and saved, select the ABP enforcement profile from the drop-down menu in the Enforcement Profiles section at the bottom half of the page, then select the Save button in the bottom right corner. Lastly, under the Summary tab, review the policy name, enforcement type, default profile, and rules for accuracy. Once you've completed your review and everything looks good, select the Save button in the bottom right to save the policy. The last portion of the deployment process in ClearPass is to assign the enforcement policy to a ClearPass authentication service. Select or create an authentication service from Configuration, Services, and ensure that the config under the Service, Authentication, and Roles tabs are specified as desired. Under the Enforcement tab, select the enforcement policy created in the previous step from the drop-down menu. Validate that the displayed conditions for applying the enforcement policy are correct, then select the Save button in the bottom right. For the last step in the downloadable user role specific configuration, we return to the switch to create the role ID mapping. From the global config context, assign a role ID using the GBP role command and the role name as defined in the ClearPass enforcement profile. For both local and downloadable user roles, the final step in the app-based policy deployment process is to enable AAA authentication on client switch ports. From the interface context, enable 802.1x, MAC authentication, or both. Note that as shown in this example, these settings can be applied to a range of ports all at once. To use app-based policy with device profiles, start by creating a device profile from the global config context using the port access device profile command. Associate one or more existing CDP, LLDP, or MAC groups with this profile that define the device types to which the profile will be applied. Next, associate a local user role that will be applied to devices that match the criteria from these groups for the device profile. Note that the user role must already exist in the switch configuration. You can use the role created during the local user roles section of this presentation as an example, and remember that the role ID mapping is still required. Finally, enable the device profile. Here are a few best practices when deploying and working with app-based policies. First, avoid duplicate class entries within applied policies. Because every class entry in an applied policy is programmed as a rule in the switch TCAM, duplicates will unnecessarily consume available hardware resources. Second, ensure that any non-app-based policies or access lists applied to client ports do not accidentally block any application traffic that is intended to be classified and enforced via app-based policy. Lastly, distribute client devices across multiple chassis line cards or VSF members where possible to minimize the probability of exceeding flow table utilization thresholds. Next, we'll go over some troubleshooting commands and tips for diagnosing issues with app-based policy. The first are the commands show class ABP IP and show class ABP IPv6. Note that both commands accept identical parameters and display identical output formats. When no class name is specified, the output will default to displaying all classes of the specified type, either ABP IP or ABP IPv6. If neither commands nor configuration are specified as the output format, the output defaults to configuration. Next is show port access ABP. As with the class show commands, this command will default to displaying all configured and applied policies when no policy name is specified. Note that hit counters are only available when a policy name is specified. The output of show port access clients detail now includes app-based policy information. A new module named PackABP has been added to the debug logging feature for diagnosing app-based policy-related issues. And finally, a diagnostic dump command has been added for app-based policy to assist HPE Aruba networking engineers with troubleshooting of related issues. The diagnostics command must first be executed from the enable context to enable diag dump commands on the switch, and the advanced logging feature is not available for app-based policy. And with that, I'm going to give a brief demo of app-based policy in action. We start with a Windows client that has a few websites and social media apps bookmarked. As we have not yet enabled app-based policy on the switch the client is connected to, all sites are loading normally. As shown in the earlier example, we're going to create a policy that blocks access to the social media sites shown here, but allows all other application traffic to pass. First, I'm going to check on the status of app recognition. We can see that it's disabled globally, so I'm going to enable that first. Next, I'm going to hop over to ClearPass and create a new enforcement profile. I'll switch the template to Aruba downloadable role enforcement and give it a name and description. Then I'll set the role configuration mode to advanced and set the product to AOS-CX. On the Attributes tab, I will enter the app-based policy configuration and user role itself. The policy I'm creating will use a total of 4 classes, 2 IPv4 and 2 IPv6, with the first 2 classes matching traffic for the 3 social media platforms I showed earlier, and the remaining 2 classes matching all other application traffic. Once the classes are done, I'll next add in the port access ABP policy. As you can see, the first 2 classes specify a drop action for the social media IPv4 and IPv6 classes, while permitting all traffic matching the 2 catch-all classes. With both the ABP classes and policy complete, it's time to add the port access role. This role starts with the role name and client access VLAN for the switch. Next, I will enable app recognition as part of the role rather than enable it per interface. Last, I will add the app-based policy association itself. Now that I'm done with the ABP and role configuration, hit the Save button on the line and move on to the Summary tab. I'll do a quick check to ensure that the template, name, description, type, and attributes look OK, and then I'll save the profile by selecting the Save button in the bottom right. Alright, next is the enforcement policy. Go ahead and hit the Add button, and go ahead and give it a quick name and description first. I'll leave the enforcement type as radius, and for the default profile, I'm going to go ahead and set this to the deny access profile. Okay, moving on to the rules tab. I'm going to keep it simple and just add a single rule that will be matched if the authenticating user is part of the ClearPass local user repository. So we'll select authentication. The name will be the source. The operator will be equals. And for the value, we'll choose the local user repository. Go ahead, save that rule. And for the enforcement profile, go ahead and bring up the dropdown, and we'll select the app-based policy downloadable role profile that I just created. Everything looks good. Go ahead and save that condition. Authentication source is the local user repository. They will apply the app-based policy downloadable role profile. Go ahead and review the new policy. Everything still looks good from here. Go ahead and hit save. And that is our new enforcement policy. With both the profile and policy done, it's time to apply the policy to an authentication service. I'm going to go ahead and modify an existing service rather than create a new one. I'm not going to make any changes to the service, authentication, or role mapping settings, only the enforcement policy. So on the Enforcement tab, I'm going to change from the existing ARC policy to the new ABP policy. A quick check to make sure the policy details look correct. And I'll go ahead and hit Save to put this policy change into effect. With that, all of the ClearPass configuration steps are done. Now I need to add the role ID mapping to the switch configuration, so we're back to the console. I'm going to go ahead and map the port access role name I used in ClearPass to an ID of 100. As the final step in the deployment process, I'm going to go ahead and enable MAC authentication on all ports on line card number 3, which is where my Windows client is connected. Now that we've deployed our policy, let's go back over to the Windows client and start loading some of the websites that we tried earlier. So you notice the HP Aruba networking page loads just fine as we expect. The Airheads broadcasting channel on YouTube loads fine as we expect, but what about the last 3 links? Twitter, Facebook, and Classmates. Now these are the applications, the web apps rather, that we specified should be blocked by the port access ABP policy. So if we take a look, Twitter is having some issues loading, as we'd expect. Facebook is also having some issues loading, as we expect. And Classmates is not loading at all. So it looks like our app-based policy is working, which I could verify by checking the policy hit counts. So we'll be able to see the counters for the 3 IPv4 social classes, which we could see that traffic being dropped. We could also see the hit counter for the IPv4 catch-all class showing the application traffic that is being allowed. So that is a quick demo of app-based policy. For more information on app-based policy, refer to Chapter 16, Application Recognition and Control, of the AOS-CX 10.12 Security Guide for the 6200, 6300, and 6400 switch series. And with that, thank you very much for watching this video. Feel free to check out some of the other videos in the AOS-CX Update series, linked from the description below, and please join us on the Airheads community for more great content and discussions with HPE Aruba networking engineers, partners, and customers.